In section 4.6, we're going to formally define some of the vocabulary terms that we use when we're talking about experiments. In the last lesson, you looked at some examples of experiments and thought about what could go wrong and how we can make experiments good in design, but now we want to define some of those terms. So first, let's define again what an experiment is. An experiment is where we deliberately apply a treatment to a subject to measure their response. The subject in an experiment is the people, the animals, or the things to which the treatment is applied. Oftentimes, we think about experiments being conducted on people, but it is possible to conduct experiments on animals. For example, you could test two different varieties of dog food to see if it makes a difference in the animal's coat. Or you could test something like different tread designs on tires. The treatment is what each subject in an experiment is assigned to do or something we do to them. If you're looking at marathon runners, for instance, you might wonder if changing the type of beverage they drink during the race makes a difference in their performance. So you could assign some runners to drink water and some to drink Gatorade. The explanatory variable in an experiment is the variable that we deliberately change. And the response variable then is the variable of interest that we measure. So usually we deliberately change one variable and we want to see if it causes a change in the other. Finally, blinding is when the subject in the experiment or the experimenter does not know which treatment he or she is receiving. Oftentimes, blinding is difficult in an experiment because the person who's receiving the treatment usually knows what that treatment is. However, it is possible that the researcher might still be unaware of which treatment that person is receiving. Sometimes the experimenter might know, but the subject does not. And if we can come up with a situation where neither the experimenter nor the subject know, then that is what we call double blinding. And that's sort of best case scenario, but it's often difficult to make that happen. Now, in an experiment, sometimes we have to be aware of confounding variables. Confounding variables are variables in an experiment that may affect both the explanatory and the response variable, making it appear that the explanatory variable causes the response. And a lot of times we're not aware of confounding variables. An example that I like to discuss sometimes with students is if you look at the relationship between ice cream sales and shark attacks. And maybe you notice that over a period of time, the amount of ice cream sales at a beach goes up, and at the same time, the number of shark attacks goes up. So you might be tempted to conclude that selling more ice cream causes more shark attacks, when in reality, we have another variable that is affecting both of those, which is maybe something like the outdoor temperature. So as the outside temperature goes up, they sell more ice cream. And also, as the temperature goes up, more people swim, which causes more shark attacks. So even though they both change in the same way, it doesn't necessarily mean that one causes the other. Finally, in experiments, we like to have control. Control doesn't necessarily mean you have to have a control group, which doesn't receive a treatment. But what it does mean is that we want to keep the other variables constant so we have better evidence that the explanatory variable is affecting the response variable. So a confounding variable is a variable usually that we can't control, or maybe even one that we don't know about. But oftentimes there are variables that we can control, and in that case, we want to control them as much as possible. For example, number one, we're going to suppose that we have someone named Joe who is an avid bowler. Joe believes that using a heavier bowling ball is better than a lightweight one. And so he conducts an experiment in which he lets the 8 members of his bowling team select either an 8-pound ball or a 14-pound ball to bowl with at their next tournament. Then he compares their scores at the end, and he discovers that the bowlers with the 14-pound ball performed better. So there are some things about this experiment that are good and some that are not so good, but we want to kind of analyze these details as we go through. So first of all, the subjects in the experiment are the bowling team members. The treatments are the 2 different weights of bowling balls that Joe has decided to let the bowling team members use. So either an 8-pound ball or a 14-pound ball. So there are 2 treatments in this experiment. The explanatory variable is the bowling ball weight, and the response variable is their bowling score. So Joe is deliberately changing the bowling ball weights to see if it makes a difference in their bowling score at the end. So some potential confounding variables that may affect the results. One might be bowling ability. We might notice perhaps that there are some members of the bowling team that are just better than others. And that would be something that might make it look like the weight of the bowling ball is related to the score when it's really not. Because better bowlers might naturally pick the heavier ball. Maybe they just have more experience and their arm is stronger. And so they're going to bowl better because they have more bowling ability, not because it's the ball. Now, some variables that we can control, because we can't really control bowling ability, we can control their bowling style or technique. Like perhaps different bowlers hold the ball in a different way, and that might affect the results and their score. And so maybe that would be something we could ask all the bowlers to do, would be to bowl the same way. Another thing we could control is the lane that the bowlers use. Maybe the ball travels a little bit differently down some lanes than the other. Maybe one might not be perfectly level, for example. So we would want all the bowlers in our experiment to bowl in the same lane. So that way the effects of the lane would operate equally on all the bowlers and it wouldn't cause a difference between one group and the other. Now, whether this experiment is blind, this one we would probably have to say no, because the bowlers obviously are going to know whether they're throwing an 8-pound or a 14-pound ball. There's a pretty big difference in those bowling ball weights. Also, it's probably unlikely that Joe would not know which ball they're using, unless he leaves the bowling alley during the experiment and he only looks at their scores after the fact. Now, if that was the case, we could say yes, it would be single blind, but there's no way to make this a double blind experiment. Now, Joe did not incorporate randomization in his experiment. He just let the bowlers each pick their own ball. And that is, as it turns out, is not such a good thing. So what he could have done is he could have randomly assigned half the team to use the 8-pound ball and the other half to use the 14-pound ball. And he could have done that maybe by just putting all their names in a hat and picking out half and having them all take one type of ball and the other half use the other. Now, the reason he would want to do this is because hopefully if there are some good and bad bowlers on the team, they would get a mix of both types in each group. And so you'd have good and bad bowlers with the light ball and good and bad bowlers with the heavier ball. Therefore, it'd be easier to tell whether it was the ball that made the difference and not the bowling ability. Let's look at one more example. We have a place kicker on a high school football team, and he notices that he seems to kick the ball farther when the weather is warm compared to when it's cold. He decides to conduct an experiment to see if warm footballs can be kicked farther than a cold football. So he takes 10 similar footballs from the equipment room, randomly chooses 5 to put in the refrigerator for an hour so that the ball is nice and cold, like they would be using on a cold weather day. And then the other 5 he will let sit in the sun for an hour so they're nice and warm. Then each ball will be placed on a tee and kicked, and the distance the ball travels will be measured. In this case, the treatments or the subjects of the experiments are the footballs, because that is what is being deliberately changed in the experiment. He's changing the temperature of the football, so the football is the subject. The treatments would be either refrigeration or warming. The explanatory variable is the temperature of the footballs, because that is what the place kicker is deliberately changing. And what he's measuring is the distance the football travels. Some potential confounding variables that might affect the results, maybe something like warm-up time. We know that the first few footballs might not go as far as the last ones kicked. So we would want to be sure that all of the football players have adequate warm-up time. And that might be actually a confounding variable that we could potentially be able to control. Now, some other things that we would probably want to control we would want to be sure that we would either have the same kicker kicking all the footballs, or if we have a variety of kickers, we would want to have each kicker kick one cold and one warm football, but it's probably better just to have the same kicker kick all the footballs. We'd want to be sure that all of the kicks go in the same direction so that if there is wind, we can have wind kind of operating the same on all the balls, not, restricting them going one direction versus the other. And we would want to make sure that all the balls are on the same tee and that the footballs are placed on the tee in the same way, so that doesn't affect the way that the ball is kicked. Now, as far as making this experiment blind, this one I think you actually could make blind, because if someone besides the kicker tees up the football, he's not going to know whether the football is warm or cold. So they would be just approaching the football and kicking it without knowing if it's warm or cold. So this one would be one that we could make blind. Now, the kicker proposes kicking all 5 of the refrigerated footballs first and then kicking the warmed footballs second. So essentially, they're not using any randomization in this experiment. The stats teacher tells them that this might cause some problems. The reason this would happen is because, again, if you look at part E, where we talked about warm up time above, we would run into that problem because of this. So if the kicker kicks all the refrigerated footballs first, they might not be as warmed up as they would be when they kicked the warmed footballs. And that might make it seem that it's the temperature of the football that makes a difference when it's really maybe just having more warm up time. We would want to randomly assign the order of the footballs. So maybe do a warm football first and then a cold football and kind of alternate so that it's not all of one or the other that are used first. And that's how we could remedy that problem. Please do assignment 4.6 in your homework packet.